This section is absolute value graphing, which I love. It's wonderful. Oh, it's great. Okay, so the first thing you should always remember, and Tristan made my day this morning by reminding me what it was, is the shape of an absolute value graph is always a V. Always. Okay? If you just remember that, it may even get you a question on the ACT.
Yes.
Because if you're on the ACT and they give you 4 functions, and one of them you see is an absolute value function, and it wants you to match the graph, and the graph is the shape of a V, you don't have to do any more. There it is. Absolute value is always the shape of a V. Okay? Now, I want everybody to go into Desmos.
Okay.
Desmos.
This comes. It's my better though. Is it a practice or
And I want everybody to type in y equals and use the bar that looks like you have to do shift and then the straight line, like I've got. Everybody see that?
Oh, okay. It's shift slash.
Yep, shift slash.
I got a question mark.
Shift slash.
Oh, there it is.
Shift slash. That's an absolute value right there.
This is absolute value. And let me show you why. Let's just, the next graph, hit enter, and type in y equals x.
Oh, it's a blue line. I don't like that.
Okay, so let me explain why it's a V, because maybe this will help you remember. Absolute value functions, if x is positive, y is positive. If x is negative, y is positive, right? That's the definition of absolute value. Everything that's inside the absolute value comes out positive. So these values on y equals x are when x is negative, y is negative, right? So this piece of this line at the bottom in the third quadrant has to flip up because it has to be positive, which is why this becomes a V instead of a straight line. Does that make sense?
Yes.
All the y's in the V graph are positive. Half of the blue graph is negative because y equals x, some of the values could be negative, but absolute value, none of them can. So those values from y have to flip up to the second quadrant. Okay? Go ahead and get rid of this one, the blue line. Now I want you to type in, hit enter, type in y equals negative, and then the straight line absolute value. So what happened?
It's opposite.
When you put a negative in front of this function, it flips over the x-axis. It reflects over the x-axis. This is going to be true for every function we learn from this point forward. We're going to learn quadratic functions. We're going to learn polynomial functions. We're going to learn rational functions. The negative flips it, just like it did here. I put a negative in front, and it's flipped it from the top down to the bottom over the x-axis. Okay? Let's see what happens. Go ahead and delete that one. And hit enter. And y equals absolute value. Now let's do 2 times the absolute value of x. What happened? When you put a coefficient in front of a function like this, if the number is greater than 1, it stretches the function up by that factor. So now, instead of the point 2, 2, it's now 1, 2. It's just pulled that. This point here, sorry, is 1, 1. But its counterpart in the blue graph is 2, 1. Or sorry, 1, 2. So it just multiplied the y value by 2, which forces that stretch up. Okay, what do you think is going to happen if I put 1/2 in front instead of 2?
It's going to go up, down. It's greater, it's less than. It'll get bigger, you know.
Yeah.
Okay, so let's do that. Let's just take this graph, put 1/2 in front.
Well, it's gonna be times that. Told you.
Yep. So something greater than 1 stretches the graph up. Something less than 1 pushes the graph down. Red is our original graph. Blue is what happened to it. Do you see how it went down by a factor of 2? Because it was 1/2. Okay? Still with me? All right. So let's modify this one again. Take the 1/2 out. And inside, next to the x, I want you to write, or to type, +3. +3.
That's your blessed. Oh, it's,
What happened to it?
Dang, went to the left.
mine didn't work.
It went to the left.
Wait, mine didn't work.
3 is like.
Oh, yeah. Cause I copied it.
I don't know where your graph even is.
What's happening?
I equals X.
X?
I.
Why is your scale so big?
Plus 3.
I don't know.
X is plus 3. Plus 3.
Wait, what?
And then zoom in. Why
I'm
is
so
this
confused.
Okay, nope.
Is that right?
They're too much. Go back.
I just don't
Keep
think
going.
the other ones.
Okay. Now type in absolute value x plus 3. Okay, what happened to this graph?
It moved over.
Which way did it move?
The left.
The left. Does that make sense to us?
Yeah.
Doesn't seem to me.
Oh, because that's
I added 3, but it went left.
Because
Because of the absolute value changes it.
Nope.
no.
Has nothing to do with the absolute value. If I were going to solve for x, what would I have to... Forget the absolute value for a second. If I were going to solve for x in that equation, what would I have to do?
-3.
Subtract 3 from the other side. Okay? So this is important for you to remember. It's an easy place to miss points, and it's not hard if you just remember it. And hopefully by seeing the graph, it'll help you. Anytime you add something inside the function, inside the parentheses of a function, or the absolute value sign, it's going to shift left. What do you think is going to happen if I make that sign negative?
It's gonna shift to the right.
Let's see if it works.
Yes, it worked. To the right. To the
Yep,
right.
went to the right.
To the right, to the right, to the right.
Okay, what do you think is going to happen to this graph if on the outside of the absolute value I put maybe a +2?
Oh,
Let's find out.
Let's find out.
Oh, it went up to. Oh, that's yeah, that's cool.
Went up 2.
It went too far.
Okay, so if it's inside the absolute value, it affects the x values. It shifts left or right. If it's outside the absolute value, it affects the y values. It shifts up or down. Okay, and the y value shift is actually what you think it should be. If I add something on the outside of the absolute value, it goes up. If I subtract something, it goes down. So it's only those x shifts that are opposite of what you think it should be. Okay, so if you add something inside, it's going to shift left. If you subtract something inside, it shifts right. But if you add something outside, it shifts up. Subtract something outside, it shifts down. Okay, looking at this equation and the vertex of an absolute value function is that point at the bottom of the v. If it's just y equals absolute value x, the vertex is just the origin. Do you see that in the red? 0, 0. Okay. Now I've got it. Where's the vertex now? Tell me the coordinate point of the vertex of the purple or blue line. 3, 2. So how do I get the vertex just looking at the equation?
Cover up the x, and you get -3.
So the x-coordinate of the vertex is the opposite sign of what's inside, +3. The y-coordinate is the sign that's there, 2. So you should be able to look at any absolute value graph equation and look at the equation and tell me the vertex. It's going to be the opposite of the x value, the exact value for y. Follow me? Okay. So let's just try this. If I can find where I put my stylus. Okay, everybody pay attention, please. We're going to go through this problem together, and we're going to talk about how to graph it.
Okay.
The first thing that's very helpful is to figure out where the vertex is. Where is it?
-1. No, it's 1 and -2.
Who agrees with that? 1, -2 is what he said.
Nobody else.
Yes, it should. It's the opposite sign of what's inside. Right? -1, -2. Is this sign in front positive or negative? Positive. So which direction do I expect my V to go?
Left.
My V.
Oh, up.
Up, right? If there were a negative in front, remember it flips over. So it'd be going down. Okay, so I know it's going to go up. I've handled this piece and I've handled this piece, but I've got this 3 here. Think of the 3 as a slope. When I'm graphing y equals absolute value of x, the slope of this is just 1. So it's going to go up 1 over 1, up 1 over 1, up 1 over 1 on the right side of the V, like any line. The slope of this one is 3, right? So from this point, I'm going to go up 3 over 1, up 3 over 1, up 3 over 1. And then I just, nope, now I just mirror it on the other side. Because remember, it's got to be a V. So I'm just going to take this point and mirror it on the other side. Did I do that right? That should be up 3 over 1. 1, 2, 3. Which should be here. Okay, and now I connect them. And I have my V. And if I were to graph the actual y equals absolute value of x, it would look like this. So the graph has shifted left 1, down 2, and stretched by a factor of 3.
That's a lot.
Well, all you do, find the vertex using the equation, then use whatever number's in front as the slope of half of the graph, and then just mirror it over on the other half. It's pretty easy. It's just 3 steps. Okay? Want to try another one?
Sure.
+1.
So it's going to go, the V is going to go down.
Good, because we have a negative.
It's negative. The vertex is -4 over 1.
Good. 1, 2, 3, 4, 1.
Okay, and then
The slope.
now is going to be -2 over 1.
1, 2 over. 1, 2 over. Mirror that over.
Yeah.
And connect.
There you go.
Piece of cake.
Walk in the park.
Okay, what's the domain of this function?
It's going to be where it crosses the x. So it's
Not where it crosses, that's the x-intercept. What's the domain mean?
All of them.
All the x's that are contained in this function. Well, I've got an arrow going forever to the left and an arrow going forever to the right, so the domain is all real numbers. Negative infinity to infinity. What's the range?
Negative infinity.
Well, what's the range? What's the highest number it has? 1. What's the lowest number it has?
And
Negative infinity. So I always do it from low to high. So my range is going to be negative infinity to 1.
why'd you put a bracket in?
Because it includes 1. And a negative infinity is always parentheses. Okay? So this point, if it's going down, that point is a maximum. That point is the highest that graph's ever going to get. That's a maximum. If it's going up, that point is a minimum. So the sign in front will tell you whether you're going to have a maximum or minimum on your graph. Okay? If it's got a positive sign in front, it's going to be a minimum. If it's got a negative sign in front, it's going to be a maximum. because everything's below it. Okay, let's take a look at the textbook check. If I can find it. No. Yes. Okay, at the end of the first video, you had to answer the following question. Absolute value functions will always be in the shape of a V. Good. The graph of y equals negative absolute value x will have a maximum or minimum value? Maximum value, because it's going down. The general form of an absolute value function is below. What happened? What is the vertex? HK. To graph an absolute value function using a graphing calculator, what's the abbreviation you must use?
I didn't get this one.
ABS. ABS.
So wait, would the vertex be the point?
The point that the V starts from.
All right.
Yep. Okay, ABS. And to get there,
Sounds like a bunch of pages over here.
you go to math and then number.
Oh, I was close.
Math and then number, and then the very first one says ABS.
You guys didn't know that?
Help.
Greg loves it.
I've been history for 2 years, so.
The domain of the absolute value function in the form of this will always be all real numbers.
True.
True. The domain, doesn't matter what the numbers are, it's always going to be a V going up forever, a V going down forever, so the domain will always be all real numbers. Okay? Absolute value functions. They're not hard. You just have to remember a few things. You have to know how to find the vertex. You have to know what a negative in front of the function does to the graph. And you have to know what the number in front of the function means to the graph. Okay? That is it. Unless you've got questions on 2.6.
I do.
Okay?
I don't know how to.
What's your question?
I don't know how to figure out
How to figure out what?
the inequalities.
The inequalities? Okay, so why don't I just graph one? Because there's only 3 problems, right?
There's 5.
Okay, well, there's not very many. That was my point. I'm going to graph
I have one problem left. I can
I'm going to do a triangle problem from 2.6 and show you how to do these. Okay? So the easiest equation in this shaded region is the horizontal one. Because horizontal graphs are always what equation? What does it always start with? Y equals something. And in this case, it's y equals 2. But it's not y equals. I want everything less than 2. Because that's where it's shaded. So that equation is one of the equations in my graph. Because all the y values are less than or equal to 2. Okay? Let's move to another one of these lines now. What I'm going to do is pick 2 points. These are actually a pretty easy slope. But it looks like my slope is -1, and my y-intercept is 1, 2, 3, -3. I wonder if I should make it harder because yours are harder. That one will be, well, I want to find one with a y-intercept that doesn't go through right at the y-axis. Which all of the ones I keep, it's like a magnet to a, okay. Okay, so what I'm going to do for this line is I'm going to find 2 points that it intersects. It's going to start here and it goes through this point. So I'm going to use those 2 points to find the equation of this line. Okay, I can find the slope. It's just 1, 2, 3, 4, -4, 1, 2, 3, over 3. So there's my slope. But the y-intercept isn't obvious from the graph because it doesn't go through at an integer. Okay, so what I'm going to do is use these 2 points and the equation y equals negative 4/3 x plus b, because I found my slope. Maddie, are you watching? This is for you. Okay. I'm going to plug in one of these points. So let's plug in 1, 2, 3, 4, 5. Negative 5, 0.
-5.
Yep. So that's 20/3, right? 20/3 plus b equals 0. So b is equal to negative 20/3. So my equation is going to be y equals negative 4/3 x minus 20/3. Okay? But all of your choices are in standard form.
Yep.
Okay? So the first thing I'm going to do is put this equation in standard form. So I'm going to add 4/3 x. And I'm still not done because none of your equations have fractions.
So times it by 3.
So times it by 3. Okay, so now I've got my equation. So once you've got your equation, you're going to have two possibilities. It's either going to be 4x plus 3y is less than or equal to negative 20, or it's going to be 4x plus 3y is greater than or equal to negative 20 on your choices in this problem. Okay, so how can I figure out whether it's less than or greater than? Use a test point. Okay, is 0, 0 on my line anywhere?
No.
No. So I can use it as a test point. So I'm going to plug in 0, 0 into this first inequality. 0 less than or equal to negative 20. Is 0 less than negative 20? No. It's greater than. And 0, 0 is a solution, so it's got to be this one because the solution makes this true. So that's the graph that I would pick. Then you're going to do the exact same thing for the second line. The thing that makes it easier, by the time you get to the second line, there's only two choices left. Because you know it's not an x equals or a y equals, you know it's got to be an equation, and there's only two choices left of the ones you have to pick from. So you don't even have to do all this work. You just know it's one or the other, so just use a test point and pick whether it's less than or greater than using that test point. Okay? Any other questions?
I have one on 2.7.
Okay.
I just don't understand why this is wrong.
What's the problem? You're given a graph, and is the slope, does it go down one to the right one, down one to the right one?
Negative.
Yep, it's got a, and it's flipped over the x-axis, right? What has to happen for it to flip over the x-axis? There you go. Let me look at it again. So your vertex is at 1, 1. So it's also shifted up 1, isn't it?
I just don't understand how you did it.
I didn't do anything. There you go. Plus 1.
I go, which line?
Because it went from here, the vertex is at 1, 1.
Did the bottom.
So you've got the 1 inside,
So let's do this.
and then you have to add the 1 to the outside to get your vertex.
Okay.
And then it flipped over.
Okay.
Mhm.
Can you help me on this one?
Yep, let me turn this off here.